Okay, so let's take a look at the application. The application is pretty simple. It's a tickets portal where you go and buy tickets for different concerts, let's say. And the main idea is that usually you will have more people trying to buy the tickets than the available tickets for the venue. So you will need a kind of queue mechanism in order to do like a first come, first serve approach. So this is what this page is simulating, right? So you have a queue here, and what I can do is I can go to the back office and generate some load, right? So I'm just generating 10 persons joining the queue for buying the tickets, and as soon as it's their time, their turn, they will be able to reserve and pay for the tickets, right? I've just joined the queue, and I will just generate more just to make sure that it's a normal queue, right? Like I have people in front and I have people on the back. This has a mechanism that basically will allow you to just move forward whenever like someone else already buy or abandon the queue, right? So you can abandon the queue at any time if you are not interested in buying the tickets anymore. And because I just want to go fast, I will just be able to just simulate people in front of me just leaving the queue. So I'm just removing those sessions until it's my turn, right? So that's my turn, and I just need to wait for the last person to finish buying their stuff, and then now it's my turn, right? Like, and now I can reserve the tickets. If I reserve the tickets, as you can imagine, you can select the type of the tickets and the amount of tickets that you want to buy, and you will see a bunch of IDs here, which are the ones being used for making the reservation on these things. When I click reserve tickets here, the main idea is that those two tickets are going to be removed from the pool of tickets, and that they are going to be locked until I pay for my reservation. If I manage to pay correctly, I will get the tickets. If I do not, those tickets will be, put back into, the pool of tickets, so the next one in the queue can buy them. So now I'm going to the pay systems, and as you can see here, there is a timer, but this is just the client-side timer. There is nothing enforcing this. We should build something to enforce that. So here I can just submit pay, and as soon as I click pay, this is going to go to a third-party system, which is going to process that transaction, right? And that's being done by an if iframe that's sending a request and then a callback coming back using WebSockets in order to notify that the transaction was done successfully, so we can move forward. So this is a third-party application. That's a different thing. It's hosted in a different place, and as soon as I get the response back from the service, I should be able to continue and get my tickets, right? So the payment was approved, and now I got a notification via WebSockets that this is the right thing for me to do. So I can just move forward and just see that my tickets are created there. So I have different IDs for different pieces, and now I can just download the tickets. That's kind of like the normal operation of this application, and that's kind of like the scenario that this application is trying to demonstrate. If I go back to the beginning, right here, something that I didn't mention is that when I join the queue, right, and there is still people there in the queue, all these things are being refreshed using WebSockets as well. So there is a WebSocket message coming in from the backend telling me that that there is like 6 person in the queue, and then I'm 6. When somebody else goes out of the queue, I will just get another message via WebSockets. So just for you to understand a little bit about the architecture and what kind of components you will need to have in the backend in order to route those messages to your clients.